Okay, perfect. Let's start off with these questions. I want you to be responsive. And if I ask you a question, that's fine if you don't know the answer, but just say that you don't know. Okay, so that we can move on. It's fine if you don't. Now let's solve all of these questions. These are all past paper questions. You can see, the question and where it's from as well. Okay, let's check it out. We'll solve question number 3 and question number 4 today. Hopefully, we'll be able to complete it. And if we get time, we'll solve the next one as well. Okay. So, question 3, part A, complete figure 1.1 to indicate whether each of these quantities is a vector or a scalar. Vector or a scalar? Let's check. So, acceleration is vector. It's absolutely vector because the direction is extremely important, right? Positive acceleration is different. Speed is a scalar. I haven't taught you power yet, but power is a scalar quantity as well. Okay. Question part B. A ball is projected with a horizontal velocity of 1.1 meters per second from point A from point A at the edge of the table as shown in figure 1.1. Okay, okay. At point B, which is a distance. Okay, so we know that the range of the ball is 0.43 from the base of the table. Okay. Calculate the time taken for the ball to fall from A to B. Okay. First of all, if you want to calculate the time taken for the ball to range or, to fall from A to B, I think it's easy because if you have the horizontal velocity and you have the horizontal distance, you can simply use V is equals to displacement over time, right? And you can use it for the horizontal version, right? Because you have the horizontal speed, you have the horizontal distance, and you just divide and then get time. So T is basically just going to be S over V. Now, what was the range? That was 0.43 meters. What was the velocity? That was 1.1 meters per second. And what does the answer come out to? The answer came out to be 0.43 divided by 1.1. Okay, so the answer is 0.391 second. Is that the answer? Does anyone have a different one? Which determine the height of the table. Okay, I'm going to move on now. If you have a problem, you can, stop me right there. If not, I'm just going to move on to the next question. So then it says use your answer in B1 to determine the height of the table. So that means it took like 0.391 seconds. I'm just going to write that as 0.39 seconds to reach from here to here. Okay, the ball fell from the table and you reach point B. Okay, so that means he's now asking me to calculate h, which is basically the vertical distance, right? That means I'm now going to have to use all vertical suvats. So what is the s that I'm trying to find out? Height. That's exactly what I want. What is initial vertical velocity? Vy at this point is 0. The ball has no vertical velocity at this point. It's just, moving completely horizontally. Okay. Then u is just going to be 0. What is v? What is v? Can we find out v over here? Basically, we're trying to find out what is Vy over here. We can actually find that out, but we might not need it. We check. Okay, V, we'll leave it at unknown for now. What is acceleration? It's just minus 9.81. And what is T? T is exactly this, 0.391. Okay. Yes, RS, what do you think? Which equation of motion should we use? Because V square minus U square or S is equals to UT plus half AT square. Which one do you want to use? Does this seem more appropriate?
Yeah, because we have the time, right?
Exactly we do. And this negates this value because u is 0. So 0 plus 1 over 2 into minus
But then again, if you
9.81.
wanted, you could still also use the other one, right?
Exactly, we could, but then for that we would have to find out v, right? We would have to then
And
find out
also, like,
v.
aren't they telling
Hmm,
us to use the answer from B1? So we have to, like, use that,
exactly.
right?
But in order to calculate v, you will have to use this value, right? Because in order to calculate v, you will first have to use the first equation of motion. V is equals to u plus at,
Oh,
right? And
yeah.
then when you find out V, and then you will plug it over here, and then you will find out S. That's one way to do it as well. Okay. So this is just easier one, less steps. So H turns out to, let's check, let me check. So this comes out to 1 over 2 into minus 9.81 into 0.391. So that is minus 1.91 meters. Yep, that's right. That is, although you don't really have to include the negative sign over here because that's just the height. Although displacement is minus 1.91, which implies that from your starting point, you are negative 1.91 meters from your starting position, assuming that this is zero displacement. Since you fell down, that is going to be your displacement value. Okay, moving on. The ball leaves the table at time t is equals to 0. For the motion of the ball between A and B, sketch graphs to show the variation with time t of acceleration of the ball. Acceleration is going to be the same throughout the entire journey. And we know that g is going to be minus 9.81 meters per second square. What is the vertical component SV of the displacement? Vertical component of the displacement SV. Okay. Now that's interesting. Any ideas on what the graph would look like for vertical displacement? This is basically height with respect to time. Yes. Any suggestions? Hania, Kaima, what do you think?
Will it like go
Yes,
up and
Aris.
reach the peak and then come back down?
Like this?
Yeah, something like that. Oh wait, no, no.
Okay. It's
Uh,
time t, where time t is the ending point. So that means you've got to draw the graph of height with respect to time, right? Initially, you had zero displacement, right? You had zero displacement, and
yeah.
then displacement
So,
started to increase. It's either a straight line or it's a curve like this or like this. That's the problem, right? Because you saw that the vertical component was increasing. The ball kept falling and it kept increasing its, vertical displacement.
oh yeah.
So what does the graph look like? Yes, Hania, any answers?
Is
What
it
do you
a
think?
decreasing curve? Because like the vertical
Uh,
component
like
starts
this?
decreasing.
Like this?
No, the other way.
The other way. Okay, but how do you think we should be sure?
Yeah, I'm not sure
Yes,
exactly.
okay. Yes, Kaima,
Oh,
what do you think?
I have a question.
Yes, yes.
For the previous question, the one before this, I think
Hmm.
you like missed out the square root sign because I got a different answer for the
Square root?
time. I
Oh,
mean the
yes, yes,
power.
yes. Sorry. Yeah, sorry. That was squared. Yes. Sorry, 1 second. So if you square this is going to be 0.74, 0.75 roughly. Is that right? Minus 9.81 to
Yeah.
0.39. Yep, that's right. Okay, so 0.75 is correct. Okay. Yes, Kaima, what do you think? What should be the graph for vertical displacement? Vertical displacement, SV.
I also think it's a decreasing one.
Like this? Oh, sorry, like this? Okay.
Yeah.
Yes, Ares, any suggestions? What do we do? Do you see that the H value or SV, right? The vertical displacement, we literally wrote down the expression for that. It's 0 plus 1 over 2 into 9.81 times 0.39 squared. Isn't that basically SV? This is SV. So you could say SV is basically just 1 over 2 into G into T squared. Do you see that SV is directly proportional to T squared? Do you see the relationship between them? It's a it's a square relationship, right? It's a square relationship. So that means for example, if S is equals to for example, if I 1 second. So for example, if let's say S is equals to T square, okay, let's forget all of this and write down S is equals to T square. So that means when time is equals to 1 second, S is equals to 1. If time is equals to 2 seconds, S is equals to, it's going to be 2 squared. So that's just going to be 4. If time is equals to 3 seconds, S is going to equal what? It's going to be 3 squared. That's going to be 9. If time is equals to 4 seconds, then S is going to be equal to 4 squared, which is going to be 16. So do you see that it's actually increasing like this? The vertical displacement is actually increasing with a factor of t squared. Does that make sense? So that means it's actually going to be an upward increasing graph, or you could say it should be an increasing slope curve. Why? Because SV is directly proportional to t squared. Does that make sense? So that means if you increase the time by 2, if you increase the time by 2, then vertical displacement is actually going to multiply by 4. Very, very important piece of information. Okay. Make sense? Okay. You can literally try to plot a graph and you will see that the graph is going to increase with an upward slope. Okay. So a ball of greater mass is projected from the table. With the same velocity, air resistance is still negligible. State and explain the effect of any of the increased mass on the time taken for the ball to reach the ground. Yes, Aris, what do you think? This is one of those excellent questions. We increase the mass. Should it affect the time taken?
No.
Yes.
Hello?
Any answers? I'm going to answer it in 10 seconds. Any answers, guys? Whoever answers it will get $1 million as a reward.
Sir, can you hear me?
One second. I think it got disconnected or something. Okay. Yes, Aris, you were saying something?
I was saying that it won't change.
Okay. It absolutely won't change. It will have no effect because if you notice in this equation, if you calculate for time, there is no component of mass anywhere in any of the equations of motion. V is equals to U plus AT, no mass. S is equals to UT plus half AT square, no mass. 2AS is equals to V square minus U square. None of them have mass. There is no mass in any single equation of motion. So that means there is no effect due to no M component in any equation of motion. And if you remember G, right? If you drop two objects that have completely different masses, they both fall at the same time, right? So if it's projectile motion, that would be the same as well. Okay. Excellent. So, Hania, makes sense? Kaima, up to this point, moving on. Question number 4. Who solved question number 4? Did anyone solve this question completely? Who did?
No.
Yes. No. What? How much did you solve it? Or not at all?
No, I just finished the first question.
Okay. Yes, Anya.
I did till part C, but I'm pretty sure I messed up.
Part D? Okay. That's fine. Part
Part
D
C.
was. Did you solve part C?
Yeah, till part C, everything before then part C.
Oh, before. So you haven't done part C.
I've
Okay.
done part C. I haven't done
Okay.
part
Okay.
D.
Okay. Yes, Kaima. Did you solve this question? Question before? Any of it?
No.
Okay. Let's solve it. It's very, very important question. It's an extremely important question. It's like one of the most challenging, velocity time questions out there. And if you get this question, you have 1 second. Okay. So it says that this is a velocity time graph of two cars, car P and car Q. I'm going to use a blue line for car P. So this is a blue line for car P, and I'm going to use a red line for car Q. Okay. So car Q has a velocity time graph like this, and car P has a velocity time graph like this. Okay. So red is car Q, and then blue is car P. Make sure you remember that, because I'll be solving the solutions with the color, so you're clear with it. Okay. The cars travel in the straight line along a straight road. Car Q passes car Q at time t. Okay, okay. So at some car Q, okay, so that means at this point, both cars are together. Okay. But do you see that at starting point, car Q is actually starting from rest. It has zero velocity and then it starts to accelerate at a constant acceleration. Whereas car P was already moving at that point. So that means you could imagine that if you had a road like this, if you had a road like this, right? Okay. At this point, car P had some amount of velocity, which was what? At t is equals to 0, car P had 20 meters per second of speed. Okay. Whereas car Q was at rest. Okay. So at this point, it was at rest, and then car Q started to move on later. Okay. It moved on later. Okay. So it started to accelerate at this point, but car P was already moving. Okay. Very, very important piece of information. This was car Q and this was car P. Okay. So the speed limit for the cars on the road is 100 kilometer per hour. State and explain whether Q exceeds the speed limit. Okay. Okay. Whether car Q exceeds the speed limit. So how do you find out the speed limit? First of all, this is in meters per second. Okay. Now we're doing it for car Q. So let's use the red color. So first of all, what is the maximum speed of car Q? Maximum speed of car Q, that is basically just 30 meters per second. 30 meters per second. First of all, you've got to somehow convert the kilometer per hour into meters per second. Okay. How about we convert the car Q's velocity into kilometer per hour? If you remember, 1 meters per second is supposed to be 3.6 kilometer per hour. You can just use the ratio method to solve this question. Okay. Now, if 1 meters per second is 3.6 kilometer per hour, doesn't that mean that 330 meters per second is going to be what? Is going to be 3.6 multiplied by 30? 30, right? Let's check what that is. Right? If 1 meters per second is 3.6, then 30 is going to be multiplied by 30. So, no, wait, I think I did something wrong. No, we did it right. Okay. 3.6 into 30. That is 108 kilometer per hour. Okay. So that means, yes, car Q exceeds speed limit. Yes, Anya, did you get the same answer?
No, I think I messed up with the ratio stuff.
Okay. Are you sure we did it right? Once again. What was the car? 30. Yes. 30 meters per second, right? And if you know that 1 meter per second is 30, it is 3.6 kilometer per hour. That means 30 meters per second is just going to be, it's just going to be X. And if you do it like this, it's just going to be like 3.6 multiplied by 30 is equals to X, right? So that's just 3.6 multiplied by 30, which is 108 equal to X. Okay. So that's how you will get answer for this one. Okay. You can convert the speed into meters per second as well and then compare it. Okay. But 100 meters kilometer per hour is better. Okay. Calculate the acceleration of car P. Okay. Car P. Let's use a blue color now. Acceleration. Perfect. Now, how do you find the acceleration of car P? That's a good question. Don't you think that if you were to take the gradient of this graph, you will be able to figure out the acceleration, right? Because that's exactly what acceleration is. The slope of a VT graph is equals to acceleration. Okay. Now, acceleration is equals to change in V over change in T. Make sure you take the gradient, you take the slope for this. And let's choose 2 points. So I think let's choose point, let's choose, which point should we take? I think let's take this point, and let's take uh this point. Or let's choose another one, wait. I think this one is better. Is it? Yes, it is. Let's choose this point. So let's read it off from the x-axis. This is going to be what? This is going to be 2.4, 2.8, and 3.2. So this is 3.2. Okay. And what is it on the y-axis? That is 21. 21. Okay. So this is x1 and y1. Okay. Now let's choose this point. Now this point is this one, which is going to be 11.6. No, this is 10.4, 10.8, 11.2, 11.6, and then 11.4, 11.6. So this is going to be 11.6. And then this is going to be, correct me if I'm wrong, if I'm reading it wrong. This is going to be 21, 22, 23, 24. 24. This is going to be x2 and this is going to be y2. Okay. 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 So now, if you want to calculate the acceleration, by the way, you could do one other thing as well. You have to show the gradient, by the way. You will not get 2 marks if you do not show that you calculated the acceleration off of the slope. Okay. So car P, y2 minus y1 over x2 minus x1. So what was y2? That was 24 minus 21. And what was the change in time? That was 11.6 minus 3.2. 3.2. Let's calculate it. Yes, Anya, what did you get? 24 minus.
I got 0.33, but I chose like different points also.
Okay, that's fine. 11.6 minus 3.2. So I got my answer as 0.357. So well, your answer was what?
I got 0.33.
Okay, 0.33. Seems close enough. Let me see if he shows the right points. But that should be right. It's close enough. So this is very close. This is 21. That's 3.2 and 21. Yes. And this line is going to be 11.6 and 24. Okay. Yes. Seems about right. Okay. So we got our answer to be 0.357. 0.357. 7 meters per second. Okay. We've calculated the acceleration of car P. Now let's move on. Determine the distance between the two cars at t is equals to 12 seconds. Okay, now that's a very, very fascinating question. Let's get this lines. Take a minute to think what the question is actually asking. Determine the distance between the two cars at time t is equals to 12 seconds. So he's basically asking me that at time is equals to 12 seconds, what is the distance between those cars? Like which car is ahead? If you remember that car P started off earlier, right? The car was already moving at a speed, whereas car Q started off immediately at this point, right? So car Q had to take much longer to reach the same distance, whereas car P was already moving, right? So that means because car P was already moving, it might have traveled more distance, whereas car q had to start right from starting its car and then reaching some amount of distance. So he's asking me what is the difference between the distance between the two cars. Yes, Hania, what did you use? What did you do? How did you do that?
I don't think I did it right, but like I tried
It's
to
fine.
find, like the area, like by using
Ah,
area under the graph.
exactly.
I found the area for each box. Like
Okay, what do you mean?
because like there's no specific like shape. Like I found like the area for each box over here in the graph.
Okay, you
And then
counted
like
all of them?
I used like a big box. I didn't like specifically use like the
Okay,
tiny box.
okay. So don't you see that this is a triangle,
Yeah.
right? So you could calculate the area of this triangle, that's it. And do you see that car P can also be made into a triangle? This is one big rectangle, and this is a triangle, right? So you can calculate the area for this and then for this and then add it up. Okay. So that's much more accurate. Let's do that. So if you want to find out the distance between the two cars, you basically just check how much distance has car Q traveled and how much distance has car P traveled, and then you take the difference between them. Okay. So car P, let's check it out for car P first. Okay. So car P is the blue one, right? So if you calculate the area under the graph for car P, that's just basically the distance or displacement by car P. So that means let's check how to calculate the area. I think if you were to take this, okay, and this. So what is the area for this triangle? 1 over 2 into what is the base? The base is 12. Multiply what's the height? So this is just 1, 2, 3, 4. So that's 24. 24. Okay. So that's just going to be area is equals to 1 over 2 into base was 12 into 24 plus you have the bigger rectangle over here as well, right? So this rectangle has a length of 12, and what is its base or length? That is 20 into 12. 20 into 12. So area is equals to 1 over 2. Yes, Kaima with me? 4
Yeah.
plus. Yes, Aris, what about you? 384 meters. Yes, Aris.
Yeah, I'm able to somewhat
Corpi.
understand you. I'm
Okay.
still trying it as well.
Okay. You're doing it as well?
Yeah, I'm like doing it simultaneously while
Okay,
like
perfect. Sounds good. Now let's calculate the distance traveled by car Q. Okay, let's use the red one now. Car Q. So this is the line for car Q. Okay. That means if you calculate the area under the graph for car Q, you will be able to tell how much distance has car Q traveled. So I think I can basically see a triangle, right? So area for this one is just 1 over 2 into base into height, which is just 1 over 2 into base was what? It was 12. And what was the height? Total height? That was 30. Let's check. 1 by 2 into 12 into 30. That is just 180. Okay, perfect. So that means between these 12 seconds, car Q had traveled only 180 meters. Okay, so at 12 seconds, car Q had traveled 180 meters, but car P had traveled 384 meters. 384 meters. Now, clearly you can see that car P, because it was already moving, it it traveled a greater distance than car P because it already had a speed at that point. So that means if you were to find out the distance between them, what you do is you basically just subtract the distance. So that means 384 minus 180 meters is the distance between them. So 384 minus 180 is just 204 meters. Does that make sense? Yes. What did you get your answer as? Yes, Anya. Did you get a close answer or something completely different?
No, I looked at the question in like a different way, which was like completely wrong.
Okay,
Instead
okay,
of like
that's
finding the
hmm.
area, I found like the small triangle that's like between Q and P. I thought we had to find like the difference.
Okay, okay. Although, wait, car Q and car P, wait. So car P. Oh, so basically what you had to do was, in fact, what you're thinking is a little bit right. If you take the area under the graph for car P, this is the area under the graph for car P, right? And what is the area under the graph for car Q? That would be this, right? So that means if you subtract the area under the graph of P from the area under the graph of Q, this will be the remaining area. You're absolutely right about that. This will be the remaining area. Okay. So that is one way to solve that, although you won't get a right answer because, you can't exactly accurately calculate this area because you can't, count all of them right. And these are a way too, partial or uncertain. Okay. So that is basically what we did. The answer came out as what? That was 204. 204. So that means if you calculate this area, that would be your answer. Okay, wait. So did I do it right? Wait 1 second. 1/2 into 30 into 12, 180. Yes. And I think I did one thing wrong. 1 into 2 into 12 into 24 plus 20 into 12. That's 384. 20 into 12. Yes. And 24 into, wait, I think I did one thing wrong. We did one thing wrong. Yes. The height. So for calculating the area for this triangle, this was for the rectangle and this was for the triangle, right? So for this triangle, I first had to calculate this area, right? Basically, what I'm doing is I'm trying to calculate the area in the graph of P, right? Now for P, this is a trapezium. I can divide it into a triangle and a rectangle. So that means I calculate this area and I calculate this area. Okay. I calculated right uh for the rectangle, but I calculated the base and the height for the small triangle a little wrong because this was the base of the triangle, which was 12, and the height of the triangle was actually 4, right? Because this point is 21 and this point is 24. Wait, it's what? Let me check again. How many boxes are there? It's 1, 2, 3, 4. Yep, this is going to be 4. So the height of this is actually 4. So that means I'm going to replace it by 12 into 4. That's why I was seeing why am I getting such a big answer. So this is going to be 1/2 into 12 into 4 plus 20 into 12. Yep, that's 264. That is 264. So the answer is actually going to be 264 minus 180. Minus 180 is going to be 84 meters. Perfect. Okay, great. Sounds good. 24 minus 21. Okay, sounds good. Let's move on. Now, finally, part D. Any problems in part C? Yes, Ariz and Kaima. Did you get this part? It's basically just calculating the area under the curves and then subtracting.
Yeah.
Yes, Kaima, did you get it?
Yes.
How? Sure?
Yeah.
Yes, okay. Part D. Now, I want you to take like 2 minutes to read this. You have all of the information and suggest what I could do. Like, just think about it. Read it yourself and you can like check all of the working earlier as well. Like, how would you approach this?
So could you show the graph as well?
There it is. He's basically asking, wait 1 second, let me just copy this graph. Here it is. Yes, Anya, what do you think? What do we do for part D?
I'm not exactly sure. I'm trying to
Did you
figure it out.
did you understand the question though? Can you
It's like telling us to
hmm.
find the point where both of them are basically intersecting, like
Oh,
at
okay.
the
The cars are
same.
intersecting, right? The cars are at
Yeah.
the same distance, right? Because if you notice, if you understand the question, initially car P was already moving. It clearly traveled more distance, right? We literally calculated it to be 264 meters, right? And car Q, because it started from rest, it only traveled 180 meters. So obviously, car P is much ahead than car Q. But if you notice, do you see that car Q has a greater acceleration, right, than car P? I can literally see it off the slopes. That must mean that car Q is going to overtake car P at some time later on, but it's not in the graph. Because the graph is only up till 12 seconds. Now that's what we're trying to figure out. What time is car Q going to surpass or cross car P? Car Q. Because car Q has a greater acceleration. I can literally see it off the slope. It has more acceleration. It has more acceleration. Yes. Yes, Aris, what do you think? What should we do? Any ideas? This is like one of those distinction level questions. If you can do this, that means, you are a great physicist and you will get an A star confirmed. But if you can do this, then I will teach you how to do this and then you can get an A star anyways. Yes, Aris, any ideas?
I'm still thinking.
Okay. Think a bit
Not
more.
sure.
I'll I'll be back in 2 to 3 minutes. Okay.
So your screen share is like blurry.
Okay. Yes. Any ideas? Should I solve it? I'll give you one hint. We are trying to find the time. We are trying to find the time when both areas under P and Q are equal. That is what we're trying to find out. At initially for 12 seconds, we saw that the area under P was greater than area under Q, and that is exactly why car P was ahead, because car P had covered a greater distance, whereas car Q had covered a smaller distance. But there is going to be a point where the area under the graphs are equal, right? Because car P was actually traveling a bit slower and car Q was traveling a bit faster. Even though car P is ahead, car Q is going to catch up at some point. Now, they tell you at this point that the velocity of each car remains constant at its value at 12 t is equals to 12 seconds. Okay. So that means, oh, that means, one second. Okay. So if you notice this graph, it says that they will continue their velocities at whatever that was. Okay. So that means car P continues its velocity. What color did we use? For car P, we had blue. So that means car P continues at this velocity indefinitely. Okay. And then it says that car Q also continues its same velocity. Okay. Now, the question is, there is going to be a point. Okay. There is going to be a point where both of their areas under the graph are equal, and at that time interval t, that is the point where car Q will surpass or pass by car P. So let's assume that this is that point. This is that point. Let's call it time t. Okay. At time t. So that means if you choose time t, we don't know what time t is, right? Time t could be like any point, it could be over here, it could be over here. We don't know what time t is. But at time t, the distance traveled by car Q, okay, is going to equal the distance traveled by car P. That's the brilliant part of this question. When both of the areas under the graph are equal, this means that distance by P is equal to distance by Q. And that's exactly when they will overtake each other, because at this point, the distance by car P is greater than distance by car Q, right? But there is going to be some point where both of these distances are equal. Do you get what we're trying to what we're trying to solve? Yes, Hania. Do you get what I'm trying to say?
Yeah, kind of. Not exactly, but like I feel like we're gonna either use like the speed formula and
We're
then
actually
find the.
going to use the area under the graph again.
Oh.
We're trying to find out the point where area under the graph for P, okay, what color did we use? The area under the graph of Q is equal to the area under the graph of P. We're trying to find out that time. Now, area under the graph for Q was what? Up till like 12 seconds. Up till like 12 seconds, this was the area under the graph for Q. Okay. And what was the area under the graph up till point P? This was this one, right? And we clearly saw that the area under the graph for P was much greater. Okay. And that's why car P was much ahead, because it has covered a greater distance. Okay. But because car Q is faster, right? At this point, if you notice, car Q has a speed of 30, whereas car P has a speed of 24. Okay. So imagine that car P, like imagine on a road, this is the road. Okay. This is car P. This is car P, which is traveling at 24 meters per second. And this is car Q. This is P, okay, and this is Q, okay. And car Q is traveling at a speed of 30 meters per second, okay. Because Q is faster, right, at this point, Q will overtake P at some point. We don't know what point, but at some point where both P and both Q are side by side, okay, this is the point, or this is the time T at which both distances are equal, are equal. And can you find out the distance traveled by car P, and can you find out the distance traveled by car Q? Yes, you can, by taking the area under the graph. That's how you do it. Okay. Now that means we're saying that at time t, both the area under the graph should be equal. Okay. So let's check what should be the area under the graph for car Q, like up till this point. Up till this point. So up till 12 seconds, the area under the graph was what? We literally calculated that earlier. That was 180 meters. 180 meters. Okay. But what about the next part of the journey, right? For car Q, you also had like this extra distance traveled, right? But we don't know what the dimensions of this are. Okay. We don't know like what is the area under for the extra distance covered. Okay. Plus, what is the length? That's just 30, right? What is the base? This is actually what? What is the length of this? Isn't it t minus 12? Right? T minus 12, right? Imagine if this is 15 and this is 12, how would you calculate this? You would just do 15 minus 12. But we don't know it's 15, right? It's T, it's unknown. It's literally what we have to calculate. So this is the distance till 12 seconds. And this is the distance till T seconds. Okay. We don't know what that is, but let's write that as it is. Okay. What about the area under the graph for P? So we have already calculated the distance traveled by P for this point, right? We literally calculated earlier, 180 meters. P, no wait, I think we switched it. For Q, I had 180 plus, yes, 30, okay. And for car P, 264 plus, okay. Now for car P, I am going to have this extra length that I'm going to calculate this area under the graph as well, okay. Now how do I do that? That is going to be, check the length of this triangle, that's just 24, multiply by, again, I don't know what the base of this rectangle is. I can just write it as t minus 12. Okay. Do you see where we're getting? Do you see that I can find out t from over here, right? Let's see. Let's see if I can add it somehow. So if I can make t the subject somehow, I can find out my answer. I can find out the time t at which they both intersect. Okay. Determine time t at which car Q passes. Okay. So let's first of all take this. So this 30 into t minus 12 equals to 264 minus 180 plus 24 into t minus 12, right? And then 30 t minus 12 there minus 24 into t minus 12 is equals to 264 minus 180. Then I think I could take t minus 12 as a subject over here. T minus 12 taken as a subject over here, which leaves me with 30 minus 24 equals to 264 minus 180. And let's see if I can solve it. 1 second. So this, by the way, is just t minus 12 into what? This is 6 equal to 264 minus 180 was what? That was 84. 84. So that means t minus 12 equals to 84 divided by 6. That means t is equals to 84 divided by 6 plus 12. I'm sure you guys want to kill yourself at this point. Plus 12. T is equals to 26 seconds. And that is the answer. So that means at 26 seconds, the car Q is going to overtake car P. The answer is 26 seconds. And check out the max for this. This is exactly why you may want to kill yourself. I get it. I understand. If I had gotten this question, I would also want to do that. But this is how some questions are solved. This is one of those, distinction level questions. You need excellent understanding and calculation techniques and measurements techniques in order to solve this kind of question. But do you see how they all link together? You need to be able to have a good mathematical understanding with connecting ideas and acceleration and trying to picture it. Because if you lack even one area in this, you won't be able to solve the question, right? It requires a lot of, but I wanted to show you that there is a way to solve the question as well. You could figure it out somehow, right? This is how, people get distinctions. This is how people get, like one of the best grades in the world or one of the best grades in, their region in Saudi Arabia, in their city or whatever, right? If you solve all of these questions beforehand, you are already aware of the tools required to solve them. Okay, so that's how you solve this question. At time t, you figure it out that both of these areas or at 26 seconds, the distance traveled by both of these cars are going to be exactly the same. They're going to be the same, which means that both of them are going to be together at that point. And after that point, the faster car will obviously overtake that car. Okay. Yes, Arez, what do you think? Do you want to hit yourself in the head right now? All for 2 marks.
Yeah, I mean, like this much for 2 marks.
Exactly. That's right. What I suggest is in the exam, don't do this question like this, okay? This is just for practice. This is just to prepare you for the exam. But on the day of the exam, because if you get this question, that means you are better equipped to solve the easier questions. Okay, my point is not to tell you to solve this question in the exam. The point of solving this question for practice is that you are now aware that there is a way to solve this question as well. There is, your concepts has now at least become a little bit stronger, right? You have understood the idea a little bit stronger, that how you can use the area into the graph and try to understand it. And it might be helpful for other questions. Maybe not this one. This question might require doing this question again and trying to picture it. That's even better, right? If you want a distinction or something. But the point is that now you know how to do this. Okay, and you will have to do it once more. Okay, that's why I've written like this is challenging. This is one of those difficult questions that nobody is able to solve, and the person that is able to solve this is the one that gets Ivy Leagues. By the way, if you get a distinction in like any one of your subjects for A levels, any like even an A star is pretty good, okay, but if you get a distinction in any of the subjects, you have guaranteed yourself into an Ivy League university, like one of the top 20 universities in the world, with 100% financial aid or scholarship or something. That's the benefits you will get. Okay, so I'm just putting that out there. If you really want to do
I
that,
thought that
then
A-star was the highest. I never knew there was like distinctions as well.
A star is the highest. A star is the highest. That's the highest grade you can get. But like within 1 to 2 months, Cambridge also announces that these students were like the best either in their city, either in their school. They were the best in their region. They were the best in this is Saudi Arabia or Dubai, or they had the best paper in all of the world. So there's a ranking. So you could have the paper which is the best in your country, right? Even that is a distinction. But having even like the best paper in your city, that's also a distinction. That also counts. The by the way, the person who has the best in the world, he obviously has the best in the world, right? So that's like much more better, right? Because if he's in the best in the world, that means he's best in every other town and every other city and every other country. Okay. Yes, Anya. Did any of it make sense?
Yeah, sort of. It was a bit confusing. Like I would have put in that work for like a
Of
2 mark
course.
question.
Yeah, understandable. That's that. I do not suggest putting that word. Like if a question like this comes in the exam, what I advise my students to do is that solve the paper always solve the paper in 2 rounds. Any question, any exam, MCQ, any test or whatever, solve it in 2 rounds. First of all, you skim through all of the paper, okay, and you started from the right, the first question, and you just start solving it. You start writing it. You start writing, you start writing and reading. And if you see that any question requires a lot of, thinking, and it requires something that you don't know, and you'll have to figure something out, circle that question, okay? Or, circle that part, for example, circle that part, leave it, and then move on to the next question. And when you move on to the next question, keep doing it, keep doing it. And if you find another difficult one, then skip it and then come to it later. So once you've done all of the easy parts where you already know the answer, you already know what to do, and you've calculated all of the stuff, after you've done all of that, then come to the second round. In the second round, what you do is you have much more time available to think and solve through those difficult questions. And even then, if you don't feel like, it's taking you too much time, just, make an educated guess, try to solve as much as you can, and then move on. Okay. Because you don't want to, spend like 20 minutes for 2 marks. It's not just worth it. It's good to know how to solve a question, because if you know that there is a method to solving a question like this, it might help you in an easier question. It might make the easier question even more easier for you. That's the point of, solving hard ones. It's the point is not to, make your life much harder. And the point is not to make you want to, quit physics and kill yourself. The point is that you have now lifted the 36 kilo dumbbells, which means you are now stronger, and you will be able to lift the 12 kg dumbbells much easily. Okay. So that's the entire point of practice. If a question like this comes in the exam, don't do it, guys. Okay, perfect. So we've got 5, 6, and 10 left. The rest of them aren't that difficult. This one was the most difficult one in all of the papers. So the rest of them are much easier. We've done most of them, or, versions of them in our class as well. Okay. I have recorded this lecture as well. If you want, you should, watch this again